Welcome, data enthusiasts and aspiring statisticians. Today we're unraveling the often confusing world of parametric and non-parametric tests. These are two types of statistical methods used to analyze data, each with its own strengths and weaknesses. Let's start by understanding parametric tests. These tests come into play when your data meets certain assumptions. The key assumption here is that the data follows a specific distribution, most commonly, a normal distribution. This means that the data is symmetrically distributed around the mean, forming a bell-shaped curve. A common example of a parametric test is the t-test. This test is used to compare the means of two groups and determine if they are significantly different from each other. To sum it up, parametric tests are like precision tools, ideal when conditions are just right. In contrast, non-parametric tests don't make assumptions about the data's distribution. This is where their strength lies, as they can handle a wide array of data types, making them the statistical equivalent of a Swiss Army knife. Picture this. You're working with data that's skewed or ordinal, say rankings from a customer satisfaction survey. Parametric tests wouldn't be the best choice here due to their assumption of normality. This is where non-parametric tests step in, handling the data with ease and providing meaningful results. A great example is the Mann-Whitney U-test, a non-parametric test that compares two independent groups. Unlike its parametric counterparts, it doesn't require the data to follow a normal distribution. This makes it not only versatile but also extremely useful in real-world data analysis scenarios, where data doesn't always play by the rules. Non-parametric tests are the statistical Swiss Army knives, versatile and handy in various situations. Choosing between these tests depends on your data. Picture a toolbox. You wouldn't use a hammer where a screwdriver is needed, right? The same principle applies here. Parametric tests, like the t-test or ANOVA, are your best bet when your data adheres to the normal distribution and you're aware of the population parameters. They're like precision tools, perfect when conditions are just right. On the flip side, if you're dealing with small sample sizes, skewed distributions, or ordinal data, non-parametric tests are your trusty all-rounders. They don't make assumptions about the population, offering flexibility when data conditions are less than ideal. Tests like the Mann-Whitney U or the Kruskal-Wallis are prime examples of these versatile tools. Remember, neither type of test is inherently better or worse. It's about understanding your data, examining the conditions, and then selecting the right tool for the job. It's all about fitting the tool to the task. Imagine you're studying exam scores, which are normally distributed from two different teaching methods. You want to know if one method is statistically better than the other. This is where a parametric test, specifically a t-test, would come into play. It would allow you to compare the means and find out if the difference is significant. Now picture a different scenario. You're analyzing customer satisfaction rankings, which are ordinal data from different products. Here, a non-parametric test like the Kruskal-Wallis test would be more apartment. It can handle the ranks and tell you if there is a significant difference in the rankings. These are but two examples of the myriad of ways parametric and non-parametric tests are used in real-world data analysis. Understanding the differences between parametric and non-parametric tests is crucial in the toolkit of any data analyst. What's your experience with these tests? Share your stories in the comments. And don't forget to like, share, and subscribe for more insights into the world of statistics.